Okay, in this short video, we will take systems of equations and turn them into augmented matrices, so that way we can use them in different contexts. Okay, for our first example, we'll take this particular system and we'll transfer it into an augmented matrix. An augmented matrix is going to take the coefficients and put them into a matrix. So you can see the coefficient to the x is 2, to the y is -1, to the in the second equation, coefficient to the x is 5, and the coefficient to the y is 2. Okay, I like to put a dotted line in here, so I'm distinguishing between the solution set. This isn't actually technically part of the matrix, but then on the other side, think of the dotted line that I'm drawing as almost the equals, and we can see that over on the other side we get a 4 and a -11. And this is called the augmented matrix, representing this particular system of two equations and two unknowns. Okay, let's try going backwards. Here's an augmented matrix. Let's take this and change it into its system. So we're going to change this into a system of equations. So what is the system representing here? We have a 3 in the first slot, so that's presumably with the x, -1 times a y, and that's supposed to be equal to a 7. In the bottom one, we have 4x, no y's, and that's equal to -8. So this is the system of equations that's being represented by that initial matrix that we had in example 2. Okay, neat. Why don't you try one on your own here? Here's an example for you to try. I put in 3 equations with 3 unknowns this time. And assuming you took a second out here, paused the video and tried it on your own, let's now try to change this ourselves into an augmented matrix. Okay, this matrix is going to be larger than the other one because we have now 3 equations. So 5x, no y's, 1z has to be equal to -1. Then we have 2 x's, -1 y, and 3 z's being 5. And finally we have no x's, 1 y, and 1 z coming out to be 12. Hopefully you got the same answer.